class, this is 16. I'm going to attempt to get through a bunch of 20. I think there's 4, like 20A, 20B, and so on. So hydrazine, N2H4 is dinitro tetraoxide and dinitrogen tetraoxide form a self-igniting mixture that has become used as rocket fuel, rocket propellant. The reaction produces N2 and H2. So we're going to put these two together. So it's nice that they give you the both of these here. So it's N2H4 for hydrazine and dinitrogen tetraoxide. Both of these are gases, probably, and then they give you, of course, nitrogen and water. Okay, so here is, of course, let's see if we can get this to work as far as balancing, because we're going to have to do, because of 4 oxygens on the left-hand side here, I'm going to have to do 4 here, which means I need at least 2 of these to get 8 hydrogens. Now, if I have 2 of those, and 4 of these, and 2 of these, that means I'm going to need like a 3 in front here, and that should do it. So 2 times 2 is 4 nitrogens, plus another 2 is 6, and 3 times 2 is 6, so that should equal. So we should be in good shape. So 2, 1, 3, 4. Now, what's being oxidized and what's being reduced? Okay, now here's what we know. We know that under most circumstances, hydrogen is positive, which makes this going to be the negative part. I don't know what that is yet, so hold on. I know oxygen is negative, so that's going to be a -8. This is, oh my, so this is going to be a plus. So each one of these is a +4, because that's a +8, because this all equals 0. So +4 going to 0, because all nitrogens on the right-hand side have an oxidation number of 0. Let's see. Ooh. So here I got a +4, which means that this must equal a -4 like that, which means each one of these, because this equals 0 also, so each one of these must be a -2. So according to my number line, I have 0 in the middle, 1, 2, 3, 4, -1, -2, -3, -4. Here I got a -2, and that's 0, and that's a +2, and that's a +4. So I got a +4 going to 0, so this is my reduction because it's going to the left. So that means this right here is getting reduced. And my -2 going to 0 is going to the right, so this is getting oxidized. Okay, that's how I see it. So what's being oxidized, that would be the N2H4, and what's being reduced, that would be the N2O4. Okay? What substance serves as the reducing agent, and which one is the oxidizing? It's just the reverse. So nothing could be easier than this. The reducing agent is the one that gets oxidized. So that would be this. That gets oxidized, so it's the reducing agent. What's the oxidizing agent is the one that gets reduced. So that would be that. Pretty simple. Moving on. Number 20. Now we are actually balancing now. We're going to go through the process of identifying the half reactions. So identifying which part is oxidation, which part is reduction, and then balance them. So we know that, let's start off with this. We know that the NO2, we know that there's a -2 for this. We know it's going to equal a -1. I have a total of -4 here, which means that this is going to be a +3 for that nitrogen. Over here, we have almost exactly the same thing, except it's going to equal -1, and this is a -6, which means that this must be a +5. This one here is a +5. So that means it looks like we have reduction here, because it's going to the right is oxidation. So nitrite to nitrate is going to be our oxidation, like that. So what we do then is, because we have same number of nitrogens on both sides, now we have to balance the oxygen with water. So 1 water on this side, and then 2 H pluses on that side to balance the hydrogens in the water. Once we get that far, here is the +3 and here's the +5. That means we need 2 extra electrons on this side, because a +5 plus a -2 equals a +3. I know that's confusing, but we got the +3 over on the left-hand side, so now the sides are equal, and that's how I know to put a +2, or I'm sorry, 2 electrons on the right-hand side. Now let's do the reduction then for the other one. Let's do Cr2O7. This has to be the reduction because there's nothing else left, and that's Cr with a +3. Now, this is going to be, because this is a -2, there we go, this is going to be a -14, because oxygen's always a -2, and that equals a -2, so that means it's +12, because that's the only thing that makes this work, which means each one is a +6, but there's 2 of them. So I put a 2 here. I go from a +12 to a +6, which means that I need an extra plus or a -6. Well, let's do that second. We'll do that after we get to balancing the waters, because we're going to need 7 waters on this side, which means we're going to need 14 hydrogen pluses on this side, and then we're also going to need 6 electrons on that side. For what I said before, 2 times +6 is a +12, like this. Over here, 2 times a +3 is a +6. So I need, on the left-hand side, I need 6 minuses to get these two to be the same. Okay, so hey, we're ready to put them together. Now this is going to be a little bit easier than normal, because this one, I have 6 electrons on the bottom on the reduction, and I have 2 electrons being transferred on the oxidation, which means this whole top thing here, I'm going to multiply all of it by 3, and that will give us 6 and 6. Okay, now that's good. Now here's what happens here. I'm going to do the water next, and what my water looks like then is 3. I'm going to take 7 minus 3, and I get rid of that completely to give me 4 waters on this side. So that's how that works. Now I'm still going to have, obviously, I still have my H pluses. I have 6 on the right-hand side and 14 on the left-hand side. So 14 minus 6 is 8 on this side, and these go completely away. And now I just write down everything else that I have, and that should do it. Plus, and what is that? 3NO2 minus, and then the other side is going to be 3NO3 minus, plus, and then Cr with a +3, but there's 2 of them there, and I got real lucky with that. Let me go back through and just check to make sure. It looks like everything matches up. 3 N's, 3 N's, 3 times 2. Oh, here we get into this whole like crazy business with number of oxygens and all that stuff. So if I go oxygens on this side, 3 times 2 is 6, plus 7 is 13. 3 times 3 is 9, plus another 4 is 13. So that actually works out. So here is our answer for 20A. 20B is going to be basically the same thing. 20C, again, very similar. 20D, you know what? That's going to be it for me. I'm going to stop here, and then I'll do 27 at the end. If you would like to see a separate screencast of one of the other 20s to check to see if you got it right or whatever, please message me and let me know.